This time we're going to learn how to do the truth tables for the conditional and the biconditional. Okay, suppose I said, if you pass the final, then you will pass the course. If you pass the final, then you will pass the course. Okay, what are the key words in that sentence? If, then. And so if you isolate those connectors, you can clearly see how many simple statements there. 2, good. The first one would be, you pass the final, and the second one, you will pass the course. Okay, since there are 2 simple statements, there's 4 possible things that could happen here. Okay, so there's your P, and there's your Q. Okay, case 1, you pass the final and you pass the course. I did what was promised, so the statement is true. Okay, so when you're looking at if-then statements, you're looking to see, was a promise broken? And if a promise was broken, then the statement is false. Okay, but in this scenario, you pass the final, and I said if you pass the final, you'll pass the course. Well, you pass the final and you pass the course, so what I said was true. Case 2, you pass the final, but you don't pass the course. But wait, I told you that if you pass the final, you would pass the course, and that didn't happen. So I broke my promise, and therefore the statement is false. Okay, so the if part happened. The if part was true, and somehow the then part was false, and so that makes the statement false. Okay, case 3, you don't pass the final, but you do pass the course. Well, that might not be what you expected, but I never said what would happen if you didn't pass the final. Okay, so I never put a condition on that. So therefore, what I said was still true. I said if you pass the final, you pass the course. So this actually just was irrelevant to what I said. So what I said was still true. Okay, case 4, you don't pass the final and you don't pass the course. Again, I never said what would happen if you don't pass the final, but you probably would have expected to not pass the course if you didn't pass the final. Okay, so what I said was still true. So case 3 and case 4 did not affect what I said. So therefore, the if-then statement was still true. Okay, so a conditional statement is false. Here's some new vocabulary words. Only when the antecedent is the if part, is true, and the consequent, or the then part, is false. Okay, now, this is hard for some students to wrap their mind around, so you just need to remember this. The only time an if-then statement is false is when the if part is true and the then part is false. So if you need to, you can write it like this. If true, then false equals false. And that is the only time an if-then statement is going to be false. When the if is true and the then is false. Basically what this statement says, what this sentence says, but without those vocabulary words. And notice I've written an equation on the board to help you. Okay, so here's what your truth table would look like in this scenario. So I'm giving you case 1, 2, 3, 4. You guys know that you don't normally have a column for the cases, but this way you can relate it back to your notes. So the first case, well, notice that P is still true, true, false, false. Q is true, false, true, false. Because the first case was you pass the final, so P is true. You pass the course, so Q is true. And the if-then statement is true. Case 2 was that you pass the final, but you don't pass the course. So P is true, Q is false. And so I broke my promise. So notice this pattern right here. It's what I wrote right up here. If true, then false is false. Okay, third case, you did not pass the final, so P was false, but you did pass the course. I never said what would happen if you didn't pass the final, so my statement was still true. It didn't contradict my statement, in other words. And then the last one was you didn't pass the final, so P is false, and you didn't pass the course, so Q is false. But my statement is still true, because actually you probably would have expected that. Okay, so this is your standard if-then table. Okay, the truth value of a conditional statement does not change if the antecedent and consequent are reversed and both are negated. So they're saying if you reverse both sides of the if-then and negate both sides, you're going to get the same truth values in your table. So here's another way to write this. If P then Q is equivalent to if not Q then not P. Notice that we reversed the letters and negated both sides. By the way, the symbol is equivalent to can also be written with it looks like an equal sign with 3 bars. Okay, so this equal sign with 3 bars is the same as the words is equivalent to. So in other words, it's not equal, it's not the exact same sentence, but it has the same meaning, so it's equivalent. Okay, so we want to write an equivalent statement to if I live in Port St. Lucie, then I live in Florida. If I live in Port St. Lucie, then I live in Florida. Theron, you got an idea? Okay, so you negated both sides, but you had to do more than just negate both. Right. If I don't live in Florida, then I don't live in Port St. Lucie is correct. And so think about that truth value. If I live in Port St. Lucie, then I live in Florida. That is true. If I said it, okay, so Theron's first attempt was if I don't live in Port St. Lucie, then I don't live in Florida. See, that's not true. Doesn't have the same truth value. But if I negate and reverse both sides, if I do not live in Florida, then I do not live in Port St. Lucie. I don't know of any other Port St. Lucie in the world. So that statement would also be true. Okay, so that was our if-then. So now we're going to get to the biconditional, which is our if and only if. A biconditional statement, P if and only if Q, means, and we discussed this already, it means that it has to work in both directions, an if-then statement. If P, then Q, and if Q, then P. Both of those directions have to be true for the if and only if to be true. And so this would be another way that we could write an if and only if statement. If P, then Q, and if Q, then P. Now we're going to use this to prove what makes an if and only if a true statement. Okay, so according to the definition, it says a biconditional statement is true only when both of the component statements are the same. In other words, they either both have to be true or both have to be false. So let's take a look at that. Now the easy one to see is if they're both true. So if I stick in a true for both P and Q, well, if true, then true is true. If true, then true is still true, and an and statement is only true when they are both true. So that makes this statement true. So notice that since this is equivalent to an if and only if, we just proved that when both P and Q are true, then the if and only if is also true. Okay, let's take a look at when they are both false. So P is false and Q is false. Well, if false, then false is true, right? Because the only time an if then is false is when it's if true, then false. Okay, so this is still true, so therefore the other one's still true, and an and statement is only true when they're both true. Okay, so notice that when P and Q are both true and P and Q are both false, then it's a true statement. Okay, so one more. Let's take a look at when, whoops, didn't mean to reveal that yet. But that's okay, you guys could have figured that out. Okay, let's take a look at when the truth values are different. Let's say that P is true and Q is false. So that means over here we have Q false and P true. Right, so notice that the first one, if true then false, is false. And if false then true is true. But an and statement is only true when they are both true. So this one is false. Now, had we said that P was false and Q was true, then that would have meant that the second parentheses would have been our false statement. And you'd still get the same scenario there. All right, so what you need to remember for an if and only if is that it is only true when both the component statements are the same. So take a look at this truth table. If you haven't filled yours in on your handout, go ahead and do that. Okay, so P and Q still have the same pattern. And then notice that our if and only if is only true in the first row and the last row, because those are the only places where they have the same truth value. All right, so now a couple more vocabulary words. Definition of a tautology. A tautology is a statement that is always true. You might also call it an implication. Okay, if you have your handout, you have a truth table under this definition. And so those of you that don't have your handout, this is what the truth table has in there. Did I write that down right? That's the last? Okay. All right, so I want you to go ahead and attempt to fill in this truth table. Okay, let's see how you did. What should I write down for P? Okay, true, true, false, false. For Q, true, false, true, false. Good. Okay, and then an or statement is only false when they're both false, and that only happens down here. So you should have had true, 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 false. Any questions in the first three columns? Okay, so now this if-then, you may have gotten it, you may not. But this is how I like to look at it. I say, okay, notice this is your if part, and this is your then part. And so then I like to label the columns. Okay, P is the if, and the or statement is the then. And remember, the only time that this is false is when it's if true, then false. That's the only thing that's going to equal a false. Okay, so starting in the first row, if true, then true is true. Second row, if true, then true is true. If false, then true. Notice that we already broke the pattern here. Starting out if false already is not the same as the only time it's false. Okay, so if false, then true is true. And if false, then false is also true. So if it starts out with an if false, I already know it's true because it is not this statement right here. Okay, so notice that our final column has all trues. When your final column has all trues, then that's what tells you it's a tautology. Okay, so this one right here is a tautology because we have all trues. If you even have one false in there, it's no longer a tautology because a tautology is a statement that is always true. Doesn't matter what the P and the Q are. Okay, as opposed to a self-contradiction is a statement that is never true. So a statement that is never true. You have another truth table there for P and not P. So you're doing a truth table for P and not P, which means you need a column for P and a column for not P. How many different letters do you see here? One letter, which tells you that you have 2 rows in your table. So that's why on your handout I only gave you a table with 2 rows. Okay, so the only possibility for P is that it's either true or false. Then not P would be false or true. And then an and statement is only true when they're both true. Well, here we have false, false. Okay, so notice that your final column is all false. All of them came out false, so that's what shows you it's a self-contradiction. Okay, so if you have all trues, you have a tautology. If you have all false, then it's a self-contradiction. If you have a combination of trues and false, then it's neither. It's neither a tautology nor a self-contradiction. So P has true, true, false, false, and Q has true, false, true, false. And so now you have to select the truth values for not P. Okay, so I need false, false, true, true. You see how Math Excel tries to trick you there? The true and the false are not in the same order? Okay, I know. It's very tricky. All right, so now we're going to do the if-then statement here. So again, this is what I like to do. I label that my Q is the if, and the not P is the then. And so that helps me to remember, because now the reason I'm really pointing it out this way is because sometimes your columns are not in order from left to right. Those things get reversed. And so you really got to remember that it's the if part. When the if part is true and the then part is false, it's false. Okay, so first row, true or false? False, because we have if true, then false, and that's false. Okay, second row, true. If false, then false is true. Third, true, and the last one is true. Okay, so only the first row had an if true, then false. And if you like to draw the little arrows in there, then that's fine if that helps you as well. So we had false, true, 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 correct? Nice work. Okay, let's take a look at one that has 3 letters. Okay, so we have 3 different letters, which means we needed 8 rows in our table. So P, Q, and R have already been done for you. And again, don't forget that these are good opportunities to write down in your notes in case you might forget this later. Okay, now they chose to do the not R and then the not Q and then the not Q then P. Okay, it doesn't matter the order of the following columns. I probably would have done the not Q first and then done the not Q then P and then done the not R, because I just like to go in order of operations. But it's up to you, you have some leeway on which order you want to do your columns. All right, so not R, I need the opposite of R. So that means I've got false, true, false, true, false, true, false, true. Not Q. Opposite of Q. So false, false, true, true, false, false, true, true. Everybody with me on the not R and the not Q? Now we're going to do this if-then statement. So notice this time my not Q is the if and P is the then. So this doesn't go from left to right, how you've been doing all these if-thens. So the only time an if-then is false is when the if is true and the then is false. Okay, but now we're going from right to left, so be careful of your order. So we start out with if false, then true. What do you guys think? True. If false, then true. Okay, here's the same thing. If false, then true. True. If true, then true. True. If true, then true. If false, then false. If false, then false. If true, then false. Okay, that one is false. Good. And then another, if true, then false. False. Okay, so any questions on how we did that column? Okay, let me go ahead and type that in. We've got all trues except the last two rows are false. Now, the last thing, we already did the if-then, we did the not R, but now we have to focus on this symbol here. What does that symbol mean? Or. And we have an or between the not R column and the if-then statement. So everybody clear on why we're comparing those two columns? And then an or is only false when they're both false. Good. So in the first row, false true is true. True true is true. False true is true. True true is true. False true is true. True true is true. False false is false. And true false is true. So any questions on how we selected those values? Okay, so we've got true, 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 and this was the only false. True. Let's check our work. Well done. Now, by the way, before I forget, this is similar to number 13 in the book, but number 13 in the actual book has a typo in the answer key. So if you get something slightly different, it's okay, the answer key is wrong. So you can always check it with me later if you want. So, all right, let's take a look at a biconditional. So this one combines the biconditional with the conditional. P and a Q, which is already done. Then inside parentheses, we have to do the if and only if. And then the last column is the if-then statement in its entirety. So what do I know about if and only if? True when they're both the same. Good. So in the first row, true, true is true. True, false, false. False, true. And false, false. True, good, because they're the same. Okay, so now this column is your if, and Q is your then. So it's as if you're going from right to left in opposite order this way. And the only time an if-then statement is false, if true, then false. Good. So the first row, if true, then true, true. If false, then false, true. If false, then true, true. And if true, then false, false. So any questions on this one? Okay, so here it says, use a truth table to determine whether the statement below is a tautology, self-contradiction, or neither. Notice they don't give you any of the truth tables. So these are really good homework problems to practice because you have to build the truth table from scratch. And then you're going to choose from one of the three choices there. Okay, so in case this is a little small, how many different letters do you see there? 2. So we need a P and a Q. And how many rows? 4. Okay, so we need true, true, false, false, true, false, true, false. All right, notice inside the first parentheses we need not P's and not Q's. So I'm going to make a column for those. And you can do it in this order if you wish, or you can put P first. It doesn't matter. Not Q is the one that comes first, and then not P. So not Q is the opposite of Q, giving us false, true, false, true. Not P is the opposite of P, so false, false, true, true. So now I'm going to go ahead and do what's inside the first parentheses. Not Q and not P. So that means I'm looking at the not Q, the not P, and what do I know about and? Only true when they're both true. So therefore, okay, false, 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 true. Good. If you wish, you can do the other parentheses, but I might just go ahead and just go outside that parentheses and do the negation next. Get that left side done. So we have the negation, oops, let me change colors here, of not Q and not P. Now remember, when you have a negation outside parentheses, it just means take the opposite of what you just did in parentheses. So that gives us true, 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 false. Now we have to do the other parentheses. We don't have a choice. So Q and P. Okay, going all the way back to the first two columns. It's an and statement, so it's only true when they're both true. So the first row is true. Second row, third row, fourth row are all false. So true, false, false, false. Okay, and then in the very last column, now that we've done the left side and the right side, now we need the entire compound statement. You didn't think I'd fit it in there, did you? Okay. So now we're focused on the if and only if symbol. And what do we know about if and only if? When they're the same, right. That's the easiest way to think about it. So it's true when they're the same. We're looking at the last two columns that we just did. So in the first row, we have true, true. So that's true. True, false is different, so that's false. True, false is different, so that's false. And false, false is the same, so that's true. So we have true, false, false, true. But now we have to actually answer the question that they posed to us. We did the truth table. And so the question is this a tautology, a self-contradiction, or neither? Neither is correct, good, because you have a mix of truths and falses. So we're going to pick that first choice right there. So any questions when they're asking you whether it's a tautology, a self-contradiction, or a neither? Good job. Okay, let's take a look at this problem here. So this one gives you this long statement, and it wants you to come up with what P, Q, and if you need an R. Now, in here, they already told you what P, Q, and R is. But if you're doing the ones in the book, they're not going to tell you what those simple statements are, and you need to write them out for yourself. Okay, I'll guarantee you right now that you'll have a problem like that on the test where you have to figure out what the simple statements are yourself, and you have to define what letter is going to stand for what statement. So make sure that you're practicing a couple of these from the book. This is number 61 in the book, so that area, so that you can do it without Math Excel's help. All right, so let's just see how Math Excel came up with this P, Q, and R. The original statement is, you'll love performing the magic trick if and only if you're good at sleight of hand, or you won't be able to pull off the trick. Sorry, you won't be able to pull the trick off. Remember that whenever you see a sentence, the first thing you should do is identify what keywords you see in there. So what keywords do you see in this sentence? Okay, if and only if, or, won't. Good. There's a hidden not in here. Okay, so won't is the same as will not. And then the other thing that I sort of covered up when I circled the or that's important is the comma. Okay, there was a comma right there. So remember, the comma is important when you go to write in symbolic form because it tells you where the parentheses goes. Okay, so notice that they chose that P stands for you'll love performing the magic trick. So that's the first simple statement that we see there. Q is you're good at sleight of hand. So that's the second simple statement there. And then R, you'll be able to pull the trick off. So remember, they left off the not. So you will be able to pull the trick off. So now that you know what P, Q, and R stand for, you want to go ahead and translate this symbolically. And then you have a couple choices down here. I probably should have panned down before I wrote on the board. Okay, so multiple choice. So I want you to show me choice 1, choice 2, choice 3, or choice 4. Okay, I see a majority have chosen 2. Okay, so option B there. Let's see if you guys are right. Fantastic. All right, so just to make sure everybody understood where that came from, because some people didn't answer. So you'll perform the magic trick as P, and this one's Q, so you had P if and only if Q. And then or, not R, because you have to put in that not back in there. But then to determine where the parentheses go, now this one didn't make it too hard since they all had the parentheses in the same spot. But you had a comma right next to the or, so that's where it splits it in half, noting that you need parentheses on those 2 letters on the left-hand side there. Okay, so now continue to the next part of the statement. It wants you to make a truth table for this. Okay, there are 3 letters, simple statements, so there are 8 rows in here. And they already did P, Q, and R, but you have to figure out what should go in the next heading. So if I take a look at that last answer there, what should go in this column? P if and only if Q. Okay, they make you choose it from a drop-down menu, but don't be too challenged. You only have 2 choices here. Okay? All right, so then we know that P if and only if Q is only true when they're both the same. Okay, so we're only looking at P and Q right now. So we have true, true, but now they're different. So false, 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 true is different, and that's different. Okay, scrolling down a little bit more. These last 2 are both the same. False, 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 false. So those are both true. Okay, not R was labeled, and so not R, I need the opposite of R. And then in the final column, we need the entire statement. So choose the one that matches your answer, which was this one, correct? Okay, so we did the if and only if symbol, we did the not symbol. All that's left is the or. And what do we know about or? Only false when they're both false. So this one's true, true, false, true, because again, I'm looking at the last 2 columns here. False, true, true, true. Okay, is this a tautology, self-contradiction, or neither? Okay, neither. It didn't ask that in this problem, but I just want to make sure you're paying attention. Okay, the last question, well, let's see if we did the truth table right. Excellent. Okay, the last question asks, indicate one set of conditions that make the compound statement false or state that no such conditions exist. Okay, is this compound statement ever false? In other words, did you end up with a false in your last column? Yes, okay, so this statement is false. Okay, so it's not going to be the no such conditions exist choice. So we're going to have to take a look back at the table to see when it was false. So it was false in the 3rd row and in the 5th row, but that's it. So take a look at your original P, Q, and R in the 3rd row and the 5th row. So what did those 2 things have in common? Sorry. Okay, so R is true. They definitely have that in common. And then what do you notice about the P and Q? They're different, right? They're different signs. Okay, they have different truth values. So let's take a look at the other times that R is true. Okay, so the only time R is true is in the first, third, fifth, and seventh row. So let me circle these ones that we're focused on again. Okay, so the only other time that R is true are these other two rows that I've dotted here. Okay, so it's R is true and P and Q are different. Notice that the other time that R is true, the P and Q are the same. So it looks like we found a pattern that matches the only times that this is false. And that's what your goal is for this third part of the question. Okay, so now let's take a look at our choices. Okay, we already know that the fifth choice is not an option. Okay, no such conditions exist because it definitely is false. So now I want you guys to look at the first, second, third, and fourth choice, and you guys tell me what matches the observations that we just discussed. Okay, so go ahead and show me what choice you want. So show me 1 finger, 2 fingers, 3, 4. I think the majority is saying 2, but we have lots of mixed answers here. Okay, so choice 2, fantastic. Okay, so think about what we just said. We said that the statement is false when R is true and P and Q have opposite truth values or different truth values. Now, some of you guys said 4 because when P and Q have opposite truth values, but there were times when P and Q had opposite truth values, but R was false. So you had to you had to make note that R was a certain value. And then P and Q definitely had opposite truth values, so we could rule out those choices there. Okay, so any other questions when you're doing something like this? Okay, so now we're going to move on to the next section.